Hello everyone, my name is Ayush Sharma, and in this video I'll explain our machine learning project on heart disease prediction. So basically our goal is to predict whether a person has a heart disease or not using the medical data. The social links of all the team members and the GUI link of this model will be given in the description. First let's talk about the dataset. We have used a dataset from Kaggle which contains around 300 patient records, and each record has multiple features like age, cholesterol level, chest pain type, maximum heart rate, etc. These are some of the libraries that we have used. First, we loaded the dataset from the drive. These are the features that are in the dataset. These features are very important because they directly impact the heart health. And our target column is binary, meaning 0 indicates no disease and 1 indicates presence of heart disease. Next, we perform the data processing. We replace the missing values, and then we converted all the columns into numerical format and handled null value using mean imputation. This step is very important because machine learning models cannot work with dirty or inconsistent data. Here we have performed the train test split. After cleaning, we split the dataset into training and testing sets, where 70% of training and 30% for testing. Now, this is the process of feature scaling with the help of standard scaler. This ensures that all the features are on the same scale, which is especially important for the models like KNN and SVM that we have used in this model. Here we have trained multiple models, including logistic regression, decision tree, random forest, support vector machine, and KNN, which is K neighbors classifier. Each model is trained and evaluated using accuracy and classification metrics like precision, recall, and F1 score. And these are the accuracies of all the models. So this is the best model by far, which is the random forest with the accuracy of 81.52%. In our case, because it reduces overfitting and captures complex patterns. This is the conclusion matrix of the best model. It shows how many predictions were correct and where the model made mistakes. This is a model comparison graph which shows the random forest with highest random forest and SVM as the highest model, the highest accuracies. Sorry. Now this is the ROC curve. It shows how many predictions were correct and and where the model made mistakes, as well as it tells how well the model distinguishes between classes. The closer the curve is to the top left, the better the model, the better the model will perform. This is the correlation heat map. We observe that a feature like cholesterol, chest pain type, and heart rate play a major role in prediction, as we can see in the correlation heat map. So the final conclusion is that machine learning can effectively predict heart disease using patient data. However, our dataset is small, so for real-world performance, we need larger dataset and possibly deep learning models.
So this is our health AI model, which basically take the patient data and predict the risk for heart diseases. Okay, so the patient have to provide all this detail according to their report, and just click on predict heart disease. Based on the user input, it predict the how much risk a patient have. Okay, so based on this input, it produces high risk and also give the high risk of heart disease detected. Please consult a healthcare professional immediately. This is basically it providing a guidance to the patient to consult the doctor on this report.